Hey, hi guys, welcome to my channel. So today's video is the third part of NumPy module. In the previous two videos, we checked how we can create NumPy arrays. We also looked into how we can generate random numbers using the NumPy module. One more important thing which I want to focus on is that NumPy, when it stores data types, unlike lists, where we saw that lists can store multiple types of data, right? So if you have L is equal to, whereas in NumPy, if I convert this to an array, you can see here true got converted to a string. Because I told in the first lesson itself, true is not equal to true. It's false because one is a string and the other one is a boolean. You can see here all of them got converted to a string. Arrays can only store one type of data. Okay, can only store one type of data. Now, if I just simply do np.array of say 2, 3, 5, 6.7, you can see all of them got converted to floats because 2 dot is basically same as 2 dot 0, which is a float. The same will hold true for tables as well. So whenever we import an Excel sheet or a CSV file in the form of a table format in Python, every column can only store one type of information, one type of data. Either it has to be a string or a number or a float, whatever it is. So let's say if we have np.1s shape. So np.1s has recognized just that it requires a positional argument called shape. So if I do shift plus tab, it will tell me what kind of syntax it follows. Python inbuilt has all these documentation available, so you can look at it and understand, okay, what is happening here. You can see the first argument is shape, then is d type. So you cannot just put 2, 3 directly. You have to put again within the bracket because the first element itself is a shape specify. You can see here np.1s of 2, 3, which basically give you 2 rows and 3 columns. Similarly, you can do 4 cos 4 also. When the number of rows and number of columns are same, these are called as square matrices. Now you can see here in both of these matrices, even np.zeros, if I do, there's a function called np.zeros which will help you generate 0 values. We already saw the random int, where you specify, generate random integers. That also we saw in the last video itself, where it takes in, directly this, right? So let's say between 0 and 99, 4 plus 4. Okay. But unlike rendint, which has integers, if you look at this, so let me just close this, you have already seen it. All these are floats. Although it's one dot means floats. So here, basically, you can specify that I want it to be integers. So that is why the D type is been given to you. So D type, if I do int, now it has become integer. You can see a difference here, right? Similarly for zeros as well. Once I do D type is equal to int. So default is float. And if you want to change it, you can change it to an integer using D type is equal to int. That is what we can do. So we were talking about only the arrays. What if I want to generate a one-dimensional array? Can I do that? Yes, you can. And simply instead of a tuple, you can simply put 4. It will give you an array of length 4 filled with zeros. Similarly for ones as well. If I simply do np.1s of 3, a single number, it will give you an array of length 3 filled with ones. Apart from generating ones and zeros, what if I want to generate another fixed value, a number fixed value of certain length in the matrix? Okay, so let's say np dot full, say 3 fill underscore value is equal to 2. When you do np dot zeros of 4, it gives you zeros of length 4. When you do np dot full of 3, it will give you some array of length 3. Number of elements is 3. But you also specify with what value you want to fill with. If I fill with it, make it this 4, a full length array with fill value 0, this is same as np.zeros of 4. So the different ways of doing the same thing, guys. Okay, in Python, there are multiple ways to do the same thing. You can explore various ways. It's very flexible. Whatever suits you, whatever you can remember, whatever you are comfortable with, you can use. Instead of 1D array, can I generate a multi-dimensional array? Of course. So here you can specify, say 10, 4 rows and 6 columns only with the value which is 10. So one more thing, guys, which I wanted to let you know is that when you use random dot rand int, right, we did something like 4,99 or 200, whatever it is, and I want it in the shape of 5.6. This is what we did. Even if you take a simple example, say some number between 4 and 200, which is 81. And if I keep running this again, to give me different values. If I want to fix a particular value, I generate a number and I fix a particular value. When I run it again, it should not change. If I want to do that, there's a function called np.random seed, which will allow me to fix the number. Now, if I again run this here, it'll give me 176, right? Now, again, if I run this, it'll give me 51 to change. But if I have the random dot seed associated with it in a single cell, if I run them, both of them together, it will keep on, it will fix that value and generate only that particular value. But if I call that function out separately without the random seed, again, it will change the value. Inside, you can use any number 0, 1, 2, 3. This does not specify anything. You can simply put 0 to fix it. So, guys, that is all for today. I hope you enjoyed today's session. We'll again have some more interesting functions which you can use. We'll slowly deep dive into the matrix calculations and how to evaluate matrices in Python. Why is it important? Because slowly we'll be dealing with data structures which are much more advanced, like tabular structures, where we have the concept of column names, and we'll be doing data pre-processing using statistics. Slowly, steadily, we'll move to that part. That is why understanding these basic concepts are very important. So please like, share, and subscribe, and look forward to our next video. Thank you.